Okay, let's get started here. This isn't in our normal sequence of events for our beginners course, but something I want to put out there. I've been working on it for a while and thought I'd throw it out there and for future reference for everybody. So let's kind of get started here on what we're going to do. Okay, going to do some graphic stuff. And this is going to be what I did, not necessarily what you would ever do, but it gives you a good idea of something to start with. I'm by no means an expert on graphics. Okay, I mean I get a lot done. I've got a lot done. I'm going to show you how to build backgrounds and how to do sprites and that kind of stuff. I've done a lot of research, lots of testing, reviewed lots of the unraveled basic on how that was done. And there's many ways of doing the same things that we're going to go over. I'm going to really mainly work with two different ways of doing things, good or bad, give you some ideas, get your juices flowing on how you can do stuff. So with that, I'll start, and we're going to go back to what we've talked about before. If you don't know what we're talking about here, you need to go back to the lessons I've been doing on what MMU is and what it does. Again, a quick review. MMU registers goes from A0, FFA0 to FFAF. Task 0, which we've talked about before, again, if you don't understand that, you need to go back to the other lessons, is in the first 8 registers, A0 to A7. Task 1 is in the second 2, A8 to AF. Remember, we could switch back in between the tasks, and our memory layout will look different just by one quick instruction. Again, here's a review. You turn the system on, reboot, whatever you want to call it. Here's what it looks like. Okay. Here's our FFA0 through A7. That's our 8 registers. And here's the memory blocks that are in them. 38, 39, A, B, C, D, and F. It's the top 8 in there. And here's how they're addressed. Okay. 0, 2, 4, 6, 8, A, C, and E. Standard stuff. Okay. Task 1, when we pop that register and say use task 1, here's what it looks like. Okay, don't worry about the colors yet. It will have in our task registers in 8, 9, A, B, this is what's the 8 registers that's used, and here's what's in there. 38, block 38, and then it's going to have 30, 31, 32, 33, 3D, 3, 5, and 3F. Okay, if we go back here, we went from 8 to F, and here we're just, keeping some of them. If you see things jumping around where it doesn't look natural, I have a mouse that's kind of going out, okay, and things kind of jump from time to time. Anyway, here's where the graphics display. If you turn the system on, where the MMU finds it in blocks 30 through 33. Okay, we're going to be using these blocks here for our different screen buffers we're going to be doing for our display. And we're going to be using these two here for copying stuff back and forth. Okay, so let's take a further look at this. Okay, these are the memory blocks. Okay, it goes up higher, goes all the way up to 3F. Okay, this is a 512K system, the only thing this works on, so it goes up above. We're not going to do anything above there. And the normal display buffers is 30, 31, 32, and 33. And they need to stay contiguous, intact for the MMU to display them on the screen. Now, let's output buffer, original buffer rather. Don't worry about the C00. That's not the memory address. That's the address that you have to calculate to tell the MMU where to find what to display. We're going to be building 2 more sets of these buffers. Buffer 1, 28, 29, A, and B. We're going to call it buffer 1. Buffer 2, we're going to be 2C, D, E, and F. So remember, blocks will be swapping them in and out of our task registers and be able to work with them. Then there's a whole bunch more in here, and then down here at the bottom, we're going to load up some background pictures. Okay, for the first part of it, we're going to be using this picture 1. At the very, very end of part 2 of all this stuff, we'll put some more pictures in. Now we're just going to use memory block 0. Okay, so to start with, we're going to, again, this is how I did it. You probably won't do it this way, but you may do it this way. You can build your background however you want. You can write a basic program to give you some backgrounds of whatever you want, and however you compile them and how you display them, however you want to do yours. This is going to be the way I did mine. Okay, so now if I can find, where did it go? Okay, I used CoCo SC. Okay, so screen compiler by Paul Fitzgerald. Okay, I did some other videos on that, and again, I used that for the background for this testing here. I grabbed this one that's showing up there now off the internet. Now I'm calling it Twisty for no other reason. I guess I could have called it Pretzel, but I just called it Twisty. Okay, it's simple enough to just have a few colors in there, and does what I wanted to do. Okay, and I'm not using the Sprite compiler for building sprites. I'm building it for use as a background, and I wanted to use this as a background, and so that's what I did now. And I just got it off the internet, found it out there, I drug it down and drug it and popped it in here. Now, one thing you may want to do with the background, okay, you can scale it or crop it. You need to get to a good size. Okay, and I already did this. I scaled it down to 192 by 192, or you could crop it, which you can whatever size you want. Now, I did 192 by 192. And I don't need all the stuff down in the lower right-hand corner. I'm not doing stack blast internet. I'm going to do it the old-fashioned way. And what I need is this information up in the upper right corner. These FCBs, that's a FCB of what this whole background looks like, all 192 rows. It's a lot of information. And if you right click on it, and I can say select all, select it again, say copy. I copy all that and I put it into a text file, and I called that text file twisty.fcb. Call it whatever you want, just however you feel, just so you know where it's at, keep it where you want it. Other thing we need is the palette. Okay, what's the palette look like so we can display this again someday? Down here in the left corner is the palette that this program generated. I'll right click on it. We'll look at the distribution. Okay, it's not using a lot of colors, as you can see. Basically it's black and white, but there is a little bit of a gray in there, so it's only using 5 palette registers. The rest of them are all open. So we got mainly the black and white, and which that is visible on the screen. But I need to get a copy of this, so I'm going to do a right click on that, and down at the bottom here it says copy palette to the clipboard. So I do that, and again I save that in a file, a text file, call it whatever you want, just so you know where it's at, and you'll be able to use that. Okay, that's so much for that program. Let's head back over here. So we used the Sprite compiler. We saved them FCBs as a text file. Whatever name you want. I used Twisty. Okay, and I forgot to put on this slide to save the RGB palette. Okay, you also need to save that. Then I put together a C program that's going to do a compression of all that information at 192 rows and put out another file, a .asm file, compile that, and put that out as a bin file. So let's look at some of that. Okay, we'll start back here with our very first thing. Okay, this is the file I copied out of Paul's program. I wrote me up here in writer. I said copy all that, and there's a lot of information. 100. We don't need to see them all, but there's 192 rows of information. Now, one thing I want to mention here, and I don't know if it's in an error or plan that way. I said I wanted 192 by 192, that's square. His program puts out 192 lines down, but it put out 256 pixels across, or 128 bytes. It's okay, I can use that, but you just need to know I didn't get the 192 by 192. I got more, but it's okay. I programmed for what he put out. So anyway, that's that file there. And then I did have the C program I wrote, and you build the background however you want. I did this because I wanted to experiment with other backgrounds, not just a one-up, one-off of this, and every time I did something I had to recode the world. I just wanted something I could repetitively do. So anyway, there's a lot of notes up here because I'm 81 years old and sometimes I forget what I did last week, let alone what I'm going to do is coding this stuff here. And I make sure it's 192 up to 256 by 192. Also copy the palette, okay, to remind myself to that. And it's just what I did, okay. Execute this program, give it the name of this program and the background color, and it will build it for you, okay. It does a lot of stuff, and I got my notes in here about all the different bits that this program's going to put out. So my assembler language program, because we're gonna do some packing of stuff. We're gonna do some compression here, not no high rate scientific packing, but we're just gonna pack each one of these lines to cut the size of this file way down. Things, we got skip bytes. If it's equal to the background color, we no need to do anything, and we'll skip it. If we got to just copy 1 byte, 2 bytes, 3 bytes, or 4+ bytes, we'll compress them down. Again, I'm not going to go through this code because you may want to do something altogether different. And I don't know if you're familiar with C, you can write it in BASIC or Rex or Assembler, whichever you want to do. So I just read the file in, I put a whole bunch of stuff out in this assembler program. It goes through each line, it makes sure that commas in the right place, and it strips out, removes all the dollar signs from them FCBs. It does a lot of stuff. And then it just starts reading the file in one line at a time. It packs it, it figures out what to do, and there it ends. And down here, put an output. If it's a background color, it puts out certain bits are turned on. If not, it switches them based on 1 byte, 2 bytes, 3 bytes, or 4+, and it does, well, here it removes some characters, here it puts out. Anyway, that's just what I did. You can figure out whatever you want to do. You may not even want to do any compression. You can just do it the way you want, and that's fine. So now we've got assembler language program, okay, and here's what that C program we just looked at, here is what that program looks like. Here's what it puts out all this information it put out within there. Gives the names of the file, it puts out some equates, it puts out an arg statement of 0, some FDBs of where stuff is located, and this line here, this is our palette. Does not put that out. Remember, we had to copy that separate, so I had to paste it in here before I compiled it. Now, if you compile it without putting this in here, you get an error in compile because it can't find the tag RSB. So that's a manual step I had to go through. And down here is the picture, okay? This is that FCB file. Remember that twisty file, the beginning top 20 lines or so was nothing but white spaces. So when this compiles out, I'm going to move this over here a little bit. It comes up with, turn some bits on, and skipping 100, basically it says skip 128 bytes. So I noticed this a line I don't have to do anything with. And it goes through it, and as you get farther into that twisty, it gets a lot more information. Okay, so we don't need to look at that. The other key to it is the thing that puts out here is these first 5 double byte addresses. The first one, it tells me at 01A is where the picture is located at. See down here is 01A. The picture is located at 01A. We're going to need that to decompress it. Where's the decompression start at? Next one down is 00A. Where's the palette RGB located at? 0A. So the program knows where to find the palette. Likewise, where's the background color located at? How many columns and how many rows are in this file? The last 3 are generated by that my C program, and they're down here at the very, very end. Okay, here's all them. Here's the last 20 lines or so that were skips. Here's our last entry we put out, and I put out this information here: the background color, the columns and rows. So again, this is what we need to do. So now we've got a file that another program is going to unpack this. This program has to talk to the other program, and it talks to it right up here at the beginning. Okay, it tells it where everything inside this file, all the information it needs to know about it is right here in these 10 bytes. Okay, so it can find everything and do whatever it needs to be. So again, I had called it up here the name twisty-f for my FTB file. Okay, so now we got a file we can load, and that will be loaded. Okay, one more thing before we leave this screen. Okay, remember it was arged at 0. So whatever memory block I put it in, it's going to be at the very, very base of that block. So I'm going to somehow figure out exactly what I need to do here and swing us over to our basic program. Okay. Now, I've already loaded up a program called twisty.basic, and I'll list it off here, okay? And all we're going to do is load that file that compiled file I just showed you. And first thing we're going to do, we're going to load it up in memory block A2. Okay, remember, if you're in BASIC, you can't load in 0 or 1. You got to stay up of 4,000 or so. So I peek what's there now, save that, and I poke 0, that's the block we're going to use, block 0, and put that into, and do a load in on that file that we just looked at. And I'm offsetting it loaded by 4,000. Okay? Remember, our address is 4,000 here, but our program inside was 0, so we're adding 4,000 to get it into the correct spot. So it will load it into that block. Wherever we move that block to, it's going to be at the base of that block at 0. And then we're going to restore back to F2, and we're going to load in our program, which we haven't looked at yet, a program called Twisty02. So enough for what we're doing there. Go back to our other screen, and let's look at Twisty2. Okay, just looking, I've been talking here for quite a long time. I think I'm going to cut this off, this part 1, and we'll end part 1, and we'll start at part 2 with actually looking at the code. Excuse me, it's going to unpack that picture for us, the background, and we'll look at displaying the sprite, one method of how we're going to do that. So we'll do that in part 2. So I think I'm going to cut this one off right now.